Hi guys, welcome to Tech Powerhouse YouTube channel. So in this video I talk about how computers work, a comprehensive guide to the parts of a computer, their functions, and how applications run on an operating system. Computers have become a fundamental part of everyday life, powering everything from smartphones to supercomputers that handle vast amounts of data. But have you ever stopped to think about how these machines work, what each part does, or how they run the applications we use every day? In this article, we'll take a deep dive into how computers work, explore the essential parts of a computer, explain how applications run on operating systems, and walk through the Windows boot process. Table of contents. (1) Introduction to how computers work. 2. Key components of a computer and their functions. Central Processing Unit, CPU. Random Access Memory, RAM. Hard drive, HDD, or solid-state drive, SSD. Motherboard. Graphics Processing Unit, GPU. Power Supply Unit, PSU. Input and output devices. (3) How data is processed in a computer. 4. How applications run on an operating system. The role of the operating system. Application interaction with hardware. Process management and scheduling. (5) Understanding the Windows boot process. BIOS, UEFI initialization. Bootloader stage. Kernel initialization. User logon and starting applications. 6. Conclusion. (7) FAQs. (1) Introduction to how computers work. At their core, computers are machines that process data. They receive input, perform calculations or other actions on that input, and then output the results. While they may seem complex, computers operate through simple binary code, ones and zeros, and each of their components works together to execute tasks efficiently. Modern computers follow a basic model known as the von Neumann architecture, which dictates how data is moved through the system. 2. Key components of a computer and their functions. Let's break down the essential hardware components of a computer, each of which plays a critical role in its overall functionality. 2.1 Central Processing Unit, CPU. The CPU, often referred to as the brain of the computer, performs the majority of the calculations required for running applications and managing processes. It's responsible for executing instructions provided by software, making logical decisions, and performing calculations at lightning speed. 1. Function: fetches instructions from memory, decodes them, and executes commands. 2. Core components: the control unit, CU, and arithmetic logic unit, ALU. 2.2 Random Access Memory, RAM. RAM is a form of temporary memory that stores data and instructions that the CPU needs while performing tasks. When you open an application, it loads from storage, like an SSD or HDD, into RAM, allowing faster access and smooth performance. 1. Function provides high-speed data storage for running applications. 2. Volatile memory, data is lost when the computer is turned off. 2.3 Hard drive, HDD, or solid-state drive, SSD. Storage drives are where all your files, applications, and operating system data are saved. There are two main types of storage devices. One, hard disk drive, HDD, uses spinning disks to read, write data. 1. It's slower but typically offers larger storage capacities at lower costs. 2. Solid-state drive, SSD, uses flash memory with no moving parts, offering faster read, write speeds and lower power consumption. 2.4 Motherboard. The motherboard is the main circuit board that houses and connects all of the computer's components. It allows the CPU, RAM, storage, and other peripherals to communicate with each other. 1. Function manages data traffic between components. 2. Bus system, the communication system between components, including data and power buses. 2.5 Graphics Processing Unit, GPU. The GPU is specialized for rendering images, videos, and animations. It performs complex mathematical calculations related to graphics, and modern GPUs are also used for general-purpose computing tasks, such as machine learning. 1. Function handles all image and video rendering tasks. 2. Dedicated versus integrated. Some CPUs have integrated GPUs, while gaming and professional tasks often require dedicated GPUs. 2.6 Power Supply Unit, PSU. The PSU converts electricity from your wall outlet into the correct form, DC, that your computer's internal components can use. Without a stable and efficient PSU, your computer won't be able to run consistently. 2.7 Input and output devices. Input devices include your keyboard, mouse, and microphone, which allow you to interact with the computer. Output devices like the monitor, speakers, and printers present the results of your computer's processes. 3. How data is processed in a computer. When you give a computer an instruction, such as opening an application, a series of actions begins. The CPU fetches the instruction from RAM, decodes it into commands, and executes it. Data is passed between RAM, the CPU, and storage drives through the system bus. 1. Fetch, decode, execute cycle. 1. Fetch. Retrieve instruction from memory. 2. Decode. Interpret what the instruction means. 3. Execute. Perform the action. 4. How applications run on an operating system. Applications such as browsers, word processors, or games run on an operating system, OS, which manages hardware resources, schedules tasks, and provides a user interface. 4.1 The role of the operating system. An OS like Windows, macOS, or Linux acts as an intermediary between the computer's hardware and the applications. It manages memory, processes, input, output, and ensures applications can run without interference. 1. Key tasks. File management. Memory management. Process scheduling. Device management. Four point two Application interaction with hardware. When you open an application, the operating system allocates resources like CPU time, memory, and access to storage. The OS also handles multitasking, allowing multiple programs to run simultaneously by allocating each a certain amount of CPU time, known as time slicing. 4.3 Process management and scheduling. When an application is running, it's treated as a process. The OS ensures that each process gets enough CPU resources to function smoothly while avoiding conflicts. The OS also manages system interrupts, ensuring that higher priority tasks get processed first. 5. Understanding the Windows boot process. The boot process is how the operating system gets started when you turn on your computer. It involves several critical steps to ensure the hardware and OS are ready for use. 5.1 BIOS UEFI initialization. When you first power on your computer, the basic input-output system, BIOS, or its modern replacement, UEFI, is responsible for initializing the hardware and checking that everything is working properly. This is called post-power-on self-test. 1. BIOS UEFI tasks. Initializes CPU, RAM, and hardware components. Identifies connected devices like hard drives and USBs. Hands over control to the bootloader. 5.2 Bootloader state. Once the BIOS UEFI has completed its checks, it passes control to the bootloader. For Windows, this is usually the Windows Boot Manager. The bootloader locates the operating system on your storage drive and begins loading it into memory. 5.3 Kernel initialization. And after the bootloader loads the necessary files, the Windows kernel is loaded. The kernel is the core part of the operating system that manages system resources and allows software and hardware to interact. It sets up essential drivers, manages memory, and starts system services. 5.4 User logon and starting application. Once the kernel has initialized, the login screen appears. After logging in, Windows continues loading user-specific settings and background applications. At this point, the computer is fully operational, and you can start using applications. 6. Conclusion. Understanding how computers work, from the individual hardware components to the operating system managing processes, gives you insight into the sophisticated systems we rely on every day. The parts of a computer work together seamlessly to process data and run applications, while operating systems like Windows ensure that everything runs smoothly, from booting up to launching your favorite program. 7. FAQs. 1. What is the most important component of a computer? The CPU is often considered the most crucial component because it handles most of the data processing tasks in a computer. 2. How does RAM impact computer performance? More RAM allows a computer to run more applications simultaneously without slowing down, as it provides temporary storage for data the CPU frequently accesses. 3. What is the difference between an HDD and an SSD? An HDD uses spinning disks to store data, making it slower but more affordable. An SSD uses flash memory, offering faster performance and durability at a higher cost per gigabyte. 4. What is BIOS, and why is it important? The BIOS initializes your computer's hardware when you turn it on and checks for issues before passing control to the operating system. 5. What happens if the bootloader is corrupted? If the bootloader is corrupted, your operating system won't be able to load, resulting in errors like the infamous "boot device not found" message. I think you have enjoyed my video, so don't forget to like, share and subscribe my channel.